All right. Hello to everyone, and welcome to today's webinar. My name is Carlo Bobilas, and I'll be your moderator for this session. Today's session will be presented by Technical Marketing Engineer Robert Harris and Leader for Security Threat Research, Darren Smith. But before I hand over the mic, I do have a few housekeeping items to cover. Today's session will be recorded and made available on demand. We'll make sure to provide those details at the end. Also, we'd love to hear from you during today's presentation. So if you have a question for our speaker and are on WebEx, please feel free to send it through our WebEx question and answer panel, where our wonderful panelists are ready to respond. For those tuning into our live stream, we thank you very much for joining in as well. However, Q&A is limited via WebEx. We will have a post-event discussion thread on the Cisco Learning Network community where you can post any follow-up questions you might have. So without any further ado, I'd like to go ahead and welcome Robert. Robert, over to you.
Thank you so much, Carlo. Appreciate the introduction, sir. So welcome, everybody, and good day. Thank you for joining us for this month's Secure Analytics webinar. Our title today is New Cisco XDR Detections Showcase Webinar. And the point of today's webinar is to kind of highlight the work we've been doing to bring additional security detections into Cisco XDR platform. And we're going to look at a variety of different telemetry sources that are driving those alerts. We're going to start off here. I'm going to tell you the three different types of telemetry sources that we're going to be looking at. And then we're going to do a deep dive into those new XDR alerts. So we've got 4 different alerts we're going to highlight here today. One of them is coming from firewall telemetry. 2 are coming from AWS CloudTrail logs, and the 4th and last one is coming from the Azure activity logs. And for each of these different alerts, we're going to start off by talking a bit about the telemetry source. Then we're going to cover a description of the individual alerts, and we're going to do some demos of triggering the alert, looking at an actual attack that might happen. And then we're going to take a look at the detection actually having fired inside of our XDR platform. From there, we're going to move on and share some additional resources if you're interested in learning more about today's topics. And then we're going to wrap up today with a question and answer session. So my name is Robert Harris. I'm a technical marketing engineer. I'm coming up on 6 years at Cisco, and my focus is on secure analytics and XDR detections. Prior to coming to Cisco, I was a security researcher, and I've got a wide variety of hobby interests outside of work.
Hey, and I'm Darren. So I lead a cloud threat research team here at Cisco within the Talos organization. So we support XDR a lot with new threat detections, as well as publishing research. And yeah, before Cisco, I did a lot of threat hunting for some large corporations and some digital forensics in the government. And yeah, I also like to play music, cello and violin, and travel.
Thank you so much, Darren. Let's start things off by just briefly mentioning the telemetry types that we're going to be looking at here today. So there are 3 different telemetry types that are going to feed these new XDR alerts that we're showcasing here today. And the best way to think about the telemetry is it's kind of our raw source of data that is coming in and feeding into our detection engine. So these are just going to be countless numbers of raw logs coming in from a variety of different sources. And in the case of today's alerts we're showcasing, we're looking at firewall activity, Amazon AWS CloudTrail logs, as well as Azure activity logs. And you can see I've got a screenshot here where I'm showing those actually in our portal. We've got a total of 15 different types of telemetry that we ingest. And let me just pivot over to the portal here real quick, just to kind of show you where you can see those telemetry sources. So I'm logged into one of my demo portals here, and you can see I'm looking at all the different alerts. You can see currently, as of today, we've got 172 different alerts available. And one of the columns that we have in looking at all of these different alerts is the telemetry type up here. And if we come to this filter and go to the drop down, you can see we've got 15 different telemetry sources that are available to us, where we're going to get those raw logs into our detection engine here and make those available as sources for alerting and doing security detections off of those. So let's take a look at our 4 different XDR alerts that we're covering here today. So these are all 4 recently created XDR alerts. We're going to start off with our firewall logs and looking at an alert titled Suspicious User Agent Activity. Then we're going to move into our AWS CloudTrail logs with 2 alerts titled AWS AppStream Image Shared and AWS High Volume of API Get Password Data Call Failures. And then we're going to wrap things up with our Azure activity logs with an alert titled Azure Anomalous Run Command. If you're interested in learning more or checking out these alerts in your own portal, I've got a screenshot down there where you can see I started looking at you can just go through the alert type and you can search for any of these and then find them and get additional details from there. But let's start off with our firewall alert. So our firewall alerts are generated coming off of firewall logs, and we currently support ingesting logs from Cisco FTD and the old ASA firewall logs. And just to give you an example of kind of what we're looking at here from the current FTD offering, we're looking at logs such as a connection start, a connection end, intrusion events, so basically think IDS events, file events, and malware events. And we've got a connection start log and a connection end log, I mentioned at first, and those types of events are basically handled as if they were NetFlow or IP fixed telemetry. So we're going through and looking at the actual metadata about connections that are traversing that firewall with those connection start and connection end logs. And our first alert here is going to be suspicious user agent activity. And basically what we're looking for here is we're looking in the HTTP headers for a user agent string from the firewall data. And this particular user agent string that we're looking for is matching malware or a pattern used by malware from the Gameredin APT group. And the observation type associated with this is suspicious firewall activity. We don't have any baseline history requirements, so as soon as we see this activity happen, we will fire off of this alert. Again, our telemetry source here is going to be firewall logs, and we've got our alerts mapped to the very popular MITRE attack framework. So you can see this particular alert is mapped to the command and control tactic category, and specifically down at the technique level, it is web protocols. And let me show you something real quick here. Let's go back to the portal here real quick. And I showed you the telemetry sources a minute ago, and you'll notice the 2 columns to the right of that. We have the MITRE attack framework tactics, and then we have the individual techniques. So as you're going through and looking at the alerts, you can see how those map over here on the far right. And if you hover over any one of these red labels, we have a pop-up that comes up where we bring in the official definition from MITRE, as well as we have a link available. If you want to pivot over into MITRE, you can follow that link, and then that will take you over to MITRE and give you the full details from there. So I'm going to turn it over to Darren now to do a demo of the suspicious user agent activity alert. Go ahead, Darren.
Absolutely. Thank you, Robert. Before I get started on the demo, we've been talking about this detection in the context of an alert. Do you want to go over quickly the difference between an observation and an alert for the audience here?
Absolutely. Yeah. So we're looking at, let me just go back one slide here, and we can point that out. So the second bullet is our observation type, and we see it's listed as suspicious firewall activity. And what that is an observation is kind of the link in between the raw telemetry source that we're bringing in and the actual alert that has fired. We generate thousands and thousands of alerts every single day. Observations every single day. And what the observation is basically a notable fact about something that we saw that occurred on the network. Hey, this host connected to this new server. Hey, we saw this amount of data traverse the network or exit the network. And it's just something that's just kind of notable that we want to go through and record. So if you think of it kind of like a funnel, we start with this large subset of raw telemetry that's coming in, and then it moves down into observations. We then take those observations and then funnel them down even tighter into alerts, where the alert meets or the observations meet a certain criteria for the alert to fire, and that's what we're going to notify you on. So that's the difference between alerts and observations.
Great, thanks for that. All right, let me start my demo here. So I'm going to share a Google Chrome window. Can you all see that?
Yes, sir.
Perfect. All right. So to explain this a little bit, what this alert is looking for is a very specific format of user agent string. So it's not an indicator of compromise that we're looking for. That would be an exact match on a user agent string, which is fine, except that a threat actor then could very easily bypass that detection. So what we're looking for here instead is a format for the user agent string. And I'm showing on my screen here, sorry if it's a little bit small. If you don't know anyone in the audience, WebEx actually allows you to zoom in on a screen sharing session like this. So if it's still a little bit small, maybe try that. And anyways, this is an example of the type of format of user agent string that we look for with this threat detection. So again, it's not looking for an exact match here, but rather the format. So a URL in the user agent, and then also a computer host name and a file path in the user agent string. And then I am demoing this using open source command line utility that many of you may be familiar with called curl. But this will actually look for this user agent irregardless of the tool that makes a network request with this user agent. So if you run some custom malware, we'll still pick it up. Or if you use a built-in system utility, like living off the land binary, as we call them in the security industry, it'll pick that up as well too. So I can just show that. And the reason I chose this example is it shows that in this case, Cisco.com actually blocks requests with this user agent string, which is why I get this access denied error. But threat actors may want to do that in some cases anyway, to try things out, try out attacks using compromised infrastructure. So you still want to monitor requests like this, even if they're denied. And that's what this detection does. And then I'm going to pivot over to showing the detection in the XDR console here. So this detection is something you can see with a number of attributes. In this case, you get the user agent string, the IP address, the domain contacted, and then the endpoint that made the connection. And you can also see the underlying indicators. So this is the observation and the alert that Robert explained for you. And that's it for this demo.
Thank you, Darren. All right, let's move on over to AWS CloudTrail Logs Alerts. So let's talk about the telemetry source here for a second. We're looking at AWS CloudTrail Logs. And I've got a definition here that I got from Amazon that I've quoted on here. And the way I like to think about AWS CloudTrail Logs is when someone is interacting with AWS, pretty much everything you're doing in there is basically just an API call that is happening. And API calls are very easy to go through and log those as they're occurring. And AWS, through the use of the CloudTrail service, is providing us with access to a history of those API calls, and therefore basically all of the actions that are being taken there inside of AWS. So we get a lot of good data in there beyond just what might be happening on the wire. So some examples of things that we would be able to detect with AWS CloudTrail logs is like a domain takeover, logs being deleted, a new AWS region being created and used, someone creating an overly permissive ACL, someone deleting a security group, DNS zone creation, and so on. And really the key takeaway here is knowing that we're getting access to kind of endpoint style activity logs from AWS.
Great. And Robert, you gave some excellent examples there, but how many total AWS CloudTrail based alerts do we have in the product?
Sure. Yeah, good question. So AWS via CloudTrail gives us a lot of detail to a lot of different things happening. We've gone through and looked at those, and we've currently developed 31 different AWS CloudTrail log related alerts. That number does grow over time because again, here we're going to look at two that are very recent here. So as of today, we've got 31 specific to the CloudTrail service.
Excellent.
All right, let's look at our first AWS alert. It's called AWS AppStream Image Shared. And AppStream is an AWS service that lets you go through and stream desktop applications out without having to actually recreate those applications. So if you have those apps stored as an image, AWS allows you to share those with other accounts. And of course, there may be legitimate uses for that capability, but we also see that being used a lot for exfiltration or persistence tactics. So again, this is the observation type, kind of that middle ground there is, yes, it is an AWS CloudTrail event. We don't have any baseline history requirements, so the second that we see this happen, it will fire. And again, we're using the AWS CloudTrail logs for this. We have this mapped to the exfiltration tactic category and the transfer data to cloud account technique. And Darren actually knows something about this particular MITRE attack framework technique.
Yeah, absolutely. So as you can see there on Robert's screen, I actually contributed some information to MITRE. We work pretty closely with the attack team over at MITRE to help, broaden the industry contributions that we can make, because we provide all these detections to our customers, but Cisco and especially Talos also likes to do what we can to provide intelligence more broadly to the rest of the industry as well. So that's something I really enjoy doing, and I was honored that the attack team at MITRE included my contribution there.
Well, fantastic work, and thank you for contributing to the industry, sir. The second alert we're going to look at is called AWS. I'm sorry. Let me go to the next one here. The second alert we're going to look at is called AWS high volume of API get password data call failures. And effectively what we're looking for here, again, we're seeing those API calls coming through the CloudTrail service, and we're seeing a high volume of a call that's called get password data. We're seeing those actually fail. And when we see that high volume of those failed call attempts, it usually means you got a threat actor that's trying to figure out the administrator password for some instance that's running. So again, this is an AWS CloudTrail event observation. We do have a one-day baseline history requirement on this. So after the first day of receiving AWS CloudTrail log data, this alert will become active. And again, we are looking at AWS CloudTrail logs as the telemetry source. And we have this mapped to MITRE ATT&CK as the credential access tactic and the credentials from password stores techniques. So now that we have that out of the way, we'll turn it back over to Darren to do the demos for these two AWS alerts.
Great. Thanks, Robert. All right. Can you see that now?
Yes, sir.
Excellent. All right. So Robert did a great job describing how these alerts work, so I'm not going to go into too much detail. With the AppStream image shared one, the easiest way to do this is through the AWS command line interface. So that's what I'm using here. But just for everyone's information, you can do it through the console as well. So, just because you don't see evidence that a threat actor did this through the CLI doesn't mean that it, didn't happen. So that's just something to be aware of. And then I will quickly show how the alert works in the XDR console as well here. So this is what you'll see here. In this case, you see the source IP address. And that's pretty useful information because, if this is, say, a Tor, the onion router IP address, or maybe something from a geographically unusual region, you might find this especially concerning, right? And then you'll also see the user that performed the action, and that can also be useful because most likely in your environment, what administrators should be legitimately doing something like this, and what users are just, maybe a data scientist or someone in sales or HR, shouldn't be doing this type of action. So as well as the filtering that we have in place, you can apply those additional heuristics if you're investigating this incident. And then for the second alert, the AWS high volume of get password data calls, I'm actually going to use a open source offensive security tool called Stratus Red Team. So this is from the folks over at Datadog, and we like it quite a lot. So good job, Datadog. And I'm going to detonate this behavior. Despite the error message that actually works, that's the one weird thing with Datadog. They do sometimes display kind of erroneous error messages like that. Not Datadog, the core platform, but the open source tool, Stratus. But anyways, the behavior at an underlying level can be performed a lot of ways. So either with the AWS CLI, like I showed before, or with Stratus, like I just demoed, as well as in some cases we've seen looking into incidents at monitored customers, threat actors will write custom tooling to do this type of behavior. But anyways, this is how the alert looks in the XDR incident view. So again, you can see similar information to last time. We're showing the IP address again, as well as this time the tool that was utilized. So Stratus is written in the Go programming language from Google, also known as Golang. And that's what you'll see here is that, Go was utilized to perform this activity. And then you can see the underlying observation as well. So that's the demo for AWS.
Thank you so much, Darren.
Yep, no problem.
All right, so we got our two AWS alerts knocked out. Let's move over to our final alert here, which comes from Azure activity logs. So I've got a quote up here from Microsoft describing the Azure Monitor activity logs. And I like to think of it kind of the same way that I do with AWS CloudTrail, right? We're going through and logging any of the activity that is taken inside of our Azure environment here and making that available to us that we can feed that into XDR Analytics and run that through our detection engine. So some examples of things that we're able to go through and detect from those activity logs. And again, this is not an exhaustive list, just some that I thought were a little interesting. We can see when maybe a firewall has been deleted, a key vault's been deleted. Azure runs on the premise of network security groups. We can see when one of those are deleted, there's a OAuth bypass happening, or an Azure resource group has been deleted, or someone has taken a snapshot and made that snapshot public. And again, kind of the key takeaway we want to think about these Azure activity logs is we're getting access to kind of endpoint style activity for things that are happening on Azure.
Definitely. And Robert, you've mentioned a lot about both AWS and Azure, but do we have coverage for Google Cloud as well?
Yeah, absolutely, we do. Yeah, you're right. We've been talking about AWS and Azure in here, and the third big public cloud provider is Google with the Google Cloud Platform, or GCP as it's often called. And we do have coverage in similar coverage in with GCP. They've got an API they expose to us. So when you are going through and integrating with GCP, you're going to be tying into that API and bringing in those similar endpoint style alerts that would be coming from GCP as well. So let's take a look. Yes, sir. Let's take a look at our new Azure alert here, and it is titled Azure Anomalous Run Command. And run command is a functionality in Azure that lets you go through and basically execute commands or scripts inside of a virtual machine that you have hosted in Azure. And what we do is we have a kind of a look back on this, where we're going to go back and look at those run commands and see if they're determined to be anomalous or not. So is this something that's new that we've never seen before? So of course, there's legitimate purposes for using the Azure run command. But again, we are seeing this very commonly used by threat actors, especially APT groups, going through and gaining access to an Azure environment, and then they're executing scripts by using the Azure run command. So our observation type for this, think of that again as kind of the notable activity that we saw. We call that Azure unusual activity. There are no baseline history requirements for this, so as soon as we see this actually occur, we will fire off this Azure anomalous run command alert. Again, we're looking at the Azure activity logs as our raw telemetry source, and we have this mapped to the MITRE ATT&CK framework as an execution tactic and the cloud administration command technique. So Darren, if you would please run us through our final demo here for Azure.
Absolutely. All right. So one quick thing to note on the MITRE mapping for this. So in this case as well, Cisco is one of the named contributors. It wasn't myself personally this time around, but our team here has contributed to this MITRE attack technique as well. All right, so for this alert, the behavior it looks for, as Robert mentioned, is the use of a built-in capability of Azure called run command. And what this capability allows you to do is remotely run, well, commands, who would have guessed, on multiple VMs at the same time without directly accessing them. You can also just run it on one individual VM, which is what I'm actually doing here. But it does support that capability of running on an entire fleet of virtual machines, which, as you can guess, might be pretty useful to a threat actor. And in fact, we have seen this used in the wild by threat actors, including APT29, also known as Nobelium. The Microsoft Threat Intelligence Center reported on that. My team has also seen this used in the wild a couple of times. So that's how it works. That's the behavior we're looking for, and a few of the reasons why. So now let me show you how it looks in the XDR console. So if you see an Azure anomalous run command incident, it'll look very similar to what you might have seen for AWS, as you can tell here. So we try to unify that, so that you don't have to train newer analysts or investigators on a bunch of different UIs or interfaces. Regardless of the victim environment you're monitoring, the intelligence and investigation experience are quite similar, and we think that's a pretty helpful feature. But the information you see, again, pretty much the same. It's IP address, in this case an IPv6 address, and then the username. Azure displays them a little bit differently, but it's the same concept here. And you can also see that underlying observation that Robert was referring to. And that's it from me for the demo.
Thank you so much, Darren. Appreciate you there. All right, let's take a look at some additional resources that we have here if you'd like to learn a little bit more about topics we've covered today. Darren, would you like to take this one, please?
Yeah, absolutely. So as I was talking about before with the MITRE ATT&CK contributions, one thing that Talos likes to do a lot of is provide intelligence for the entire industry to consume. So to that end, we have a blog that is pretty frequently updated and has a lot of really in-depth reporting on everything from malware, reverse engineering, to trends and summaries of geopolitical events, entire new campaigns we're seeing, really a lot of pretty valuable content, at least we like to think. And then with each blog article, we also provide the indicators of compromise, or IOCs, for that campaign, malware, threat actor, whatever the blog may be about. So these are some examples of blog articles that we published and indicators of compromise that accompanied those blog articles for the Gamma-Redin Advanced Persistent Threat Actor, which has been attributed by various intelligence organizations to Russia. So these articles are not for the exact campaign that we wrote the threat detection for in Firewall that we covered first. That particular campaign was a pretty sensitive one with a lot of, shall we say, confidentiality agreements in place around the reporting. But this other very similar campaign that was performed by the same threat actor, the Gamma-Redin group, and targeting very similar victims, we were able to report on publicly. So that's what these links are for.
Yeah, I love jumping on the Talos blogs when those are published and just kind of going through and looking at the in-depth analysis that is included in those individual blogs. And one of my favorite parts, like for this one here that we have on the screen, which again is kind of additional TTPs to what we covered today, there's 2 GitHub links on here. And for all of the blogs where we've got published IOCs for them, we put those up on GitHub both as a text file and JSON. So it makes it really easy to go through and grab those and then use those in your different security platforms, especially if you're doing stuff with, say, like Python scripting, being able to ingest that JSON pretty easily. Those just a couple simple extra steps by putting those IOCs on GitHub really makes a huge difference in helping to feed these into your various security tools. And if you'd like to learn more about secure analytics and XDR in general, I'd like to mention the training centers that we have stood up for those. We've got a number of links in here. These slides will be made available after the presentation. We put the recording and the slides up typically about a week after these webinars occur, so you'll have access to all of those. And again, I invite you to go through and take a look at some of those other blogs as well. And let's wrap things up here today with a question and answer session. Carlo, do we have any questions?
We do. So again, if you have a question, please use the Q&A panel to submit your questions, and we'll get those answered. So the first question I have here is, how do you all choose which new XDR alerts to create? And Darren, would you be able to answer that one for us?
Yeah, absolutely. Thanks, Carla. So there's a couple of different ways here, actually. So one, and the part that I'm most involved in myself, is that Talos performs original threat research on an ongoing basis. into new and emerging threats that we've identified, especially those that target industry verticals, such as, say, education or finance, that we know we have customers in, right? So we research new and emerging techniques, malware, all of those kinds of nasty things that can affect your environment. So that's one area which is more original. The other area that leads to the creation of quite a lot of these detections is you all who are listening. So our customers often come to us with requests for ideas that they have or that would really help them better protect their environment. And we try to be as responsive as possible to those requests. So that's something to keep in mind. If you use really anything from Cisco, we're very good about listening to that input or feedback and adding in new features in response to that.
Thank you very much. All right, moving on to our next question. We use Secure Client with NVM. I know that you have alerts specific to this. Can you tell me more about NVM alerts? And Robert,
Yeah,
would you be able to answer that one?
yeah, I can take that one. I've been a part of an NVM working group here for a while and got some eyes on that. So the question is about NVM and any alerts that are surrounding NVM. So NVM stands for Network Visibility Module, and it's a subset of Cisco Secure Client. And it's an endpoint agent where we are monitoring not just what happens on the network side of the house, meaning source IP, destination IP, source port, destination port, protocol, packets, bytes, things of that nature. But we are also looking at endpoint style activity. So when you think about what we were talking about earlier with AWS and Azure, where we're getting kind of endpoint style logs from those sources, we're getting the same thing here with NVM, and we're able to marry those NVM endpoint style details with activity that took place on the network. So we can not only say, hey, this host reached out to this host using this port and protocol and this many bytes and packets at this time and so forth and so on, but we also get an inside look at the host. We can say the host was using this operating system, and here was the host name, and here was the user, here was the process that kicked off that communication, and here was the parent process of that process that kicked off the communication. We get file hashes off of that as well. So again, it's given us a lot more context of what happened on the endpoint and being able to tie that with the actions that actually took place on the wire on the network. So we go through and we have a handful of detections, and we're always creating more across the board, but especially with NVM, where we're looking for anomalous or known malicious activities that are coming from those endpoint style details. And it's really nice having all that mapped out to the network activity, and prevents an incident responder from having to go through and try and manually correlate that, especially with things like DHCP being very ephemeral. Who had this IP address at this point in time when this incident took place? You don't have to go through and look for any of that. It's all included in the same source when you're using NVM.
Yeah, and if I can add one more thing there, Robert,
Please.
we also have two alerts that utilize NVM telemetry for behavior that came out of the same Gamma Redin campaign that we talked about with the firewall. So if you have NVM and firewall in your environment. We have 3 total alerts for just that specific campaign. And if you see all 3 of those alerts fire in your environment, you should probably be kind of concerned about that. So that's another aspect of NVM.
Thank you, sir.
Yep, thank you. All right. I don't see any other questions. Robert, Darren, is there anything else you wanted to cover before we wrap up?
No. Thank you all for attending here today. Thank you for your questions, and thank you for listening to Darren and I kind of do a deep dive into our new Cisco XDR alerts and kind of show you what we do behind the scenes. Hope everyone learned something here today, and hope you all enjoyed today's webinar, and hope you all have a good rest of your day.
All right, well, thank you very much. I placed a link in the chat. It is to our post-event discussion thread. We'll make sure to post where the recording will be, along with a copy of the downloadable PDF of today's slide deck. So definitely do bookmark that, along with if you do have any other questions, comments, feedback, feel free to post them in there to continue the conversation. Your feedback is important, and at this time, you'll be directed to a survey. So we do encourage you to take the time to participate. Once again, we thank everyone for joining us today, and we will see you next time. Have a great day.
All right. Thanks, Carlo.